Finally, we will talk about conditional distributions and conditional moments this week. These are not that difficult because we know the concept of conditional probability and we know the concept of a distribution. So this is sort of a combination of the two concepts. For any event A, you can condition a distribution, the distribution of any random variable on an event. The conditional PMF of a discrete random variable will be the conditional PMF of x at k given A. So this is by definition. If you didn't have the conditioning, this would be the PMF at k is equal to the probability that x equals k. Simple as that. Okay? So here we just have the condition. So this conditional distribution, conditional PMF equals the probability that x equals k given A. Okay? And by the definition of conditional probability, you have probability that x equals k, this event, intersection with this event, the condition, okay, divided by probability of the condition. Simple as that. You see, actually there is nothing new here. You know both concepts. You know conditional probability and you know distributions. So you just merge them. For a conditional CDF, it's quite the same. If you have the CDF without any condition, this was probability that x less than or equal to x. Now you just condition it. The conditional CDF of any random variable x conditioned on event A is the probability that x is less than or equal to x given event A. So now this is the probability that x, random variable x, is less than or equal to x intersection with the condition A divided by the probability of the condition A. Simple as that. Now you see the conditional CDF can be defined for both discrete distributions and continuous distributions. If you have a continuous distribution, or in the general sense, if you have a mixed type distribution in general, you can actually differentiate the conditional CDF to obtain the conditional PDF of a continuous or a mixed type random variable, or a discrete one if you treat it with impulses. Okay, conditional PDF given A is equal to, by definition, the derivative of the conditional CDF given A. Now, based on these conditional distributions, because they are distributions at the end of the day, we can define moments of these distributions. So we have the concept of conditional moments. For some event A, we can condition the expected value or the moment of any order of random variable x given event A. Okay, it's just the same, except in the definition, you have a conditional PMF or a conditional PDF. Nothing new here. Similarly, with the conditional nth moment, you have the sum k to the power n as the nth moment definition, weighted by, instead of the original PMF, weighted by the conditional PMF. Or in the case of a continuous distribution, you have the nth conditional moment defined in terms of the conditional PDF. And you can also define conditional variance of random variable x given event A. As earlier, we have the second moment minus square of the first moment. The only difference is that now these are conditional. Okay, the conditional second moment minus square of the conditional expected value.